Hey everyone. In this video, we're going to be working on a circular motion problem, and this one I like to call friction on the road. So, an 1800 kilogram car is driving around an unbanked turn with a coefficient of friction of 0.8. Oh, decent day to be out driving. The radius of the turn is 80 meters. We need to solve what is the maximum velocity that the car can make this turn without sliding off the road. So I like asking several different variations of this problem where I give my students a velocity and have them figure out if the car slides off. In this particular problem, we're going to solve the maximum velocity. To do that, we are going to need to first determine the force of friction. Okay, we're going to think hard. The equation for force of friction is equal to mu mg. So where mu is that coefficient of friction. So our force of friction is equal to 0.8, that's our coefficient of friction, multiplied by the mass of the car, 1800, multiplied by gravity. In this case, 9.81, just because it's a resisting force. You could say friction is negative against the centripetal, but it doesn't really matter. We're just looking for a value here. So we chug that out. Our force of friction is going to equal, when we plug that out, 14,126.4 newtons. Now, this is the force that's resisting our car flying off the road. Because you see, if the force centripetal is greater than the force of friction, the car slides. We've done several problems here where centripetal force, that force that wants to fling the mass out into the wild world, is resisted by a tension on a rope. But there's no rope holding onto a car. There's no tension that's keeping it from flying. The only thing that's keeping that car from flying off the road is the friction of the tires. So we've solved the force of friction of the tires. That's like solving the max strength of a rope. The force centripetal equation is mv squared over r. Now we know our maximum force, so we're going to be able to fill that in for our force centripetal. So we can say 14,126.4 equals the mass of our car. That's the 1800 kilograms multiplied by our v squared. That's what we're solving for. All divided by a radius of 80 meters. We can clean this up and we're left with 627.84 is equal to v squared. We take the square root of both sides, and we get our velocity equals 25 meters per second. That is the maximum speed that the car can make this turn that we've described and not slide off the road. Now, just because I was curious, I went ahead, multiplied that by 3.6 just because I wanted to see, and that works out to be 90 kilometers per hour. So you could make this turn at 90 kilometers an hour and not slide off. But be careful, because you can only make this turn at exactly 90 kilometers an hour. So if you were in charge of selecting the speed limit, probably don't want to pick 90, because if the person goes 91, they go off the road. Hopefully you found this helpful. If you have any questions, please feel free to leave them in the comments down below. Thanks for watching, and I'll be looking forward to seeing you next time.